Hi guys, welcome to another video of Physics 2. In this case, we're going to see the uniform circular motion. Okay, so in the previous topics, we got objects and those objects were moving. Okay, but it's important to mention that that motion was linear. Now in this case, it's going to be a circular motion. Now I'm gonna show you a video. I'm gonna put you the video, the car of the video in the corner. So for example, this is kind of the thing that we're going to see. Okay, it's called human tangential velocity. So this person is going to gather members of the family and they're going to circle. So the important thing that I want you to look at is that, for example, the person that is in the center is the person that, as you can see, travels the least in comparison with the person that is at the end of the line. Okay, do you see that? So let's see, they're gonna integrate another person. Let's see if I can do this. Okay, a little bit. All right, I'm gonna put this video in the in the description. So if you can see, the last person is particularly running in order to travel the same distance as all of them. But it is important to mention that that distance, is not a linear distance. It's a circular distance, or a distance in degrees. Okay, so that's what we're going to see in a moment. But this is very important because if you can understand this, okay, so you can understand the whole topic about circular motion. Okay, so I'm going to begin with this explanation over here. Yes, this one over here. So, well, not that explanation. Let's see. Okay, I got that one. That one. Okay. So imagine I'm gonna have a circle. I'm gonna draw it. Okay, so a medium-sized circle, just like this. Okay, and in the center we got, well, this is gonna be the center of the circle, and imagine this is the line of people. Okay, and in here I got the last person. Okay, just like this one. So at another certain time, okay, I'm gonna have that same line, sorry, that same line over here. Okay, and the last person is over here. Okay, so we're gonna have this line is gonna be the radius. This is going to be the angle, and this is going to be the arc. So you might remember this formula from math. I don't have a video that it's gonna take me to that formula, but yes, this formula is very, very well known in mathematics. Okay, so in math, we got the definition. R stands for radius. Theta is angle, and S stands for the arc. Okay, those are the concepts that are used in mathematics, but in physics, well, those concepts change a little bit. So R equals radius. Well, in this case, is the same thing. The angle is the angular displacement. And S stands for the distance. Okay, so these are the first three concepts that we are going to see in circular motion. Now, if you remember, we got many concepts in linear motion, so many of those concepts we're going to change them, because now the letters that we're gonna see are gonna be different. So for example, I'm gonna write them over here. So if you remember, in linear motion, okay, we got x, that was the displacement, displacement, or the position or the distance. Okay, V is for velocity. Okay, A is for acceleration, and T is for time. Okay, so the only letter that we are going to use, and it will be the exactly the same, is going to be the letter T for time. Okay, we're gonna have the same time for linear motion and the same time for circular motion. Okay, so if you see, okay, I got the displacement in the linear motion and I got the angular displacement for circular motion. And when I'm talking about angular displacement, I'm talking about the degrees. So for example, in this video, if you see, okay, this over here is the angle. So if you see, all of them travel the same angle. So let's say that it could be 30 degrees. So all this person travel 30 degrees. That is the angular displacement. That is very, very different from distance. But before we continue in that, talking about that, let's write the formula. So angular displacement, angular displacement equals the distance over the radius. Okay, now what are the units? Okay, the units are gonna be the same for both. Okay, because the units could be centimeters or meters or kilometers or miles or feet or inches, as you wish. But it is very, very, very important that both have the same units, both in centimeters, both in meters, both in kilometers. Okay, so I'm gonna circle this equation. This equation is the angular displacement. This is going to be the first equation that I'm going to use. And the units for the angular displacement are really, really, really important. They are radians. Radians. That's very important because most of the time the students got the answer wrong because they write degrees. Okay, so it's very important that you understand that the angular displacement is measured in radians. Of course, you can transform those radians into degrees, but the first units that you are gonna get by solving these equations, this equation over here is going to be radians. Okay. Now, if we are going to work with radians, well, you need to have a formula in order to transform radians into degrees. Okay, so the formula is going to be, well, the formula that I use is something like this, is degrees over 180 equals radians over P. Okay, this is a formula that we're going to use. I'm gonna use it in a moment. I'm not gonna say that this is the second equation because this is a math formula. Okay, well, now I got the radians and the angular displacement. So if you remember, in linear motion we got an equation that was something like this: final position equals initial position plus initial velocity in x, and that multiplies the time plus acceleration in x that multiplies time raised to the square over 2. If you remember the previous two topics about parabolic throw and horizontal throw, in those topics we got that the initial position was 0 meters and the acceleration in x was 0 meters per second square. So if I do that, okay, so I can cancel the initial position and also this concept over here, and finally I got this formula. Position, remember that I got rid of the f because with this equation I can find the position at any given time. So position equals bx that multiplies the time. Okay, so if I want to isolate velocity, so it will be velocity in x equals the distance that is going to be divided by the time. Okay, so I'm not going to say that I'm going to use this equation, but I'm going to use it because I want to compare. This is the equation for linear motion with zero acceleration. So that means that the velocity is constant. If you see the topic over here, it says uniform circular motion. Uniform means that the velocity is going to be constant. I repeat, uniform means that the velocity is going to be constant, but I'm going to put it as a quotation marks because in the next video we're going to see that that might be not true. But in this video, okay, it's going to be uniform, so there is no acceleration. If there is no acceleration, there is no change in the magnitude of the velocity. So the magnitude, this is very important, the magnitude of the velocity is going to remain exactly the same. So I'm going to use this equation in order to find the angular velocity. So angular velocity, I'm going to use the letter W, okay, W. Okay, this means angular velocity, okay? So the angular velocity equals the distance. According to the previous equation, it says, okay, I need the distance, but in this case, I'm not use this distance. I'm going to use the angular displacement. So angular displacement is going to be divided by t. So I mean time. Okay, so that will be time. That is the equation. What are the units? Well, remember that the angular displacement is going to be measured in radians, and time could be seconds, hours, minutes, days, and so on and so on and so on. I mean, there is no depending on the problem. Okay, it depends on the problem. So I'm gonna circle this equation over here. I'm gonna say that this is the second equation, and the units for the angular velocity, well, most of the times are radians over seconds. Okay, but also could be radians per hour or radians per minute. Okay, it depends on the problem. Okay, now most of the times they're not gonna in the problem they are not gonna tell you an exact number about the angular displacement. I mean, let's say this person displaced 2 radians. No, they're not gonna say that. In many problems, they're gonna mention something different. For example, they're gonna say, okay, that person traveled a circle, one circle. Okay, so one circle equals, I don't know, 360 degrees. Okay, so by telling you a word, you need to know the angular displacement. So a circle could be equal to 1 lap. Imagine that that lap is a circle. Also, this could be known as 1 cycle. Okay, also could be a revolution, 1 rep. Okay, this concept of key over here, 1 revolution, you can see it in the dashboard of the cars, just like this. Okay, revolutions per minute is a measure of angular velocity. So a revolution is 1 lap, is 1 circle. So in this case, the motor of the car travels 1,000 revolutions in 1 minute. Okay, so 1 circle, 1 lap, 1 cycle, 1 rep. Okay, those are equal to 360 degrees or 2p radians. Okay, so I'm gonna circle this, and I recommend you to have it as very important, because in the problems they might not tell you the exact number of the angular displacement. They could be using one word as a circle or lap or cycle, I don't know. It could be many things, just like the next example that we're going to see. So if you want to write it, okay, that would be very good. And this is the, okay, let's see, here it is. Okay, here it is.